Hi, welcome to the Science Talks at UNU-EHS. I'm Austin from the Communications Department. I'm sitting here with Caitlyn Eberle, who is a senior researcher and lead author on the Interconnected Disaster Risks Report. We're here to talk about the issue of space debris. So when you see, for instance, a satellite or a space object crashing down into Earth, that has to do with the issue of space debris. And this talk will go in more depth on the issue. So Kate, I wanted to ask you first, this issue kind of seems very far removed from things going back down on Earth. Why is space so vital to societies? And what kind of things are we using space to help our societies move?
Well, our satellite infrastructure is vast. It comprises of many different orbits, each functioning in very different ways. There's satellites up there for GPS navigation. So when you need to navigate on your phone to a restaurant or so, that is a satellite communicating to your phone. Otherwise, communication satellites provide network connectivity, internet in many rural places. And satellites also provide Earth observation for monitoring the way the Earth changes and warning us and helping us prepare for an oncoming disaster, for example.
Okay, yeah. I think those are great points. And I think one thing that's so important to this conversation is that we sort of take the activities or the things that we need space for, we take these things for granted. And these activities that we're doing are not without risks. And I think this is something that the report gets at, is that, when we send things into space, they are risks and threats to their functioning, whether that's a collision or something else happening in space. Those will have impacts for us down here on Earth. So what are the risks of our activities in space? What are the things that could potentially happen?
One of the biggest risks for our satellite infrastructure is actually the existing infrastructure that's up there that is just left there. So oftentimes we send up satellites and either pieces fall off or they become broken and they are left in orbit to become a sort of obstacle for the rest of the satellites that are orbiting that could potentially be hit. So there's around 35,000 objects tracked in space, but only 25% of those are working satellites. The rest of it are these either small, tiny pieces or large size of rockets that are up there, that when we send more and more satellites up, they have the potential to collide and create more debris and break apart and destroy that infrastructure.
Wow, sounds very serious, obviously. And I think that's one of the a really interesting point about this Interconnected Disaster Risk Report, is that you get at applying a tipping point to these various case studies. There's actually 6 of them in total in the report, and space debris is just one of them. Could you explain what a tipping point is? It's nice that you mentioned that there's the risk is of collision, and you also mentioned that we're sending more and more things up into space. So what is a risk tipping point, and then perhaps what is the risk tipping point for space debris?
A risk tipping point in the Interconnected Disaster Risks Report is defined as the point at which a system, like our satellite infrastructure system, stops functioning like we expect it to, stops buffering the risks that we are relying on it to protect us, the point where that fails and the system fundamentally changes into something different and more risky. So for our satellite infrastructure, this risk tipping point is met at a critical density of objects in space, where the chance of a collision occurring becomes far more likely. And once this collision happens, then it will set off a chain reaction around the orbit that makes the orbit unusable.
Okay. And with these risk tipping points, and especially with this space debris case, we're already on some sort of path to reach these. And I think one point that's also quite interesting for the space debris case is that collisions have actually happened in space. How common of occurrence is of a collision in space, or perhaps the probability that something might happen?
There have been a few instances of collisions in the past. A very famous one between two satellites that created millions of pieces of debris that are still up there today. Luckily, right now, space in our orbits is not unmanageable. We have systems in place for active satellites to dodge each other. There's monitoring, but as we send more and more satellites up there, this monitoring and evasion tactics, where a satellite can dodge a piece of debris or avoid an oncoming satellite, it's becoming harder and harder. And you're getting more of these alerts and more of these collision warnings. And if we don't have a system in place to take care of the junk that's already up there and level out the amount that we're sending up now, it could get really dangerous. Yeah.
And I kind of want to bring it back down to the effect on Earth as well. So you mentioned at the top that we rely on our space-based infrastructure for things like GPS. What would happen if a catastrophic collision does happen in space? What types of things may not function as we would like them to, or may cease to function completely? And perhaps what are the impacts on people?
So the highest risk of collisions right now is happening in low Earth orbit. That's the orbit that's closest to the Earth. And the satellites here are the ones that are responsible for this Earth monitoring and for early warning systems, and now more and more for satellite communication, the satellite internet, for example. So when collisions were to happen in this orbit, there's a high likelihood that it could impact these Earth observation satellites, meaning that early warning systems can be compromised. People might not be warned about an oncoming disaster as quickly as they would have otherwise, giving them less time to prepare and more chance that people would be hurt or impacted in some other way. Mitigating this onslaught of debris and the dangers that this pose would actively protect people from those adverse impacts.
Okay, thank you. Now I kind of want to also kind of understand this space debris case in line with sort of the other cases within the report. Some of them deal with things like insurance, or they deal with more physical parts of our environment. So the space debris case is sort of very interesting in itself. It's happening in space. What sort of separates this space debris case from the others? And why is it such a unique case that tells us sort of about our human behavior and how we're heading towards these tipping points?
It was one of the more interesting cases, the space debris case, because it's so far removed from what's happening actually on the ground that we don't often think about the satellites that are above our heads every day. In fact, we often take them for granted, I would say. So bringing that aspect to the report and saying this thing that you don't even think about is in danger and would have a real impact on lives on the ground, it really matters. Hey, let's pay attention. So I think that was the most interesting aspect of it. And the other interesting aspect is also how it's interconnected with the other cases. So it's called the Interconnected Disaster Risks Report. So we're looking at also how this case can influence other cases. We looked also at groundwater depletion across the world. And if we were to reach a tipping point in the space debris case, let's say some of these satellites that monitor the groundwater and how much water is actually left in these underground storage places, if those were destroyed, we would have one less tool to manage groundwater depletion, and we would increase the risk that system could tip as well.
Okay, wow, that's quite a hefty sort of message, I think, with this, that all of these tipping points are interconnected. So it gives you more fuel for thought to think about how our activities around Earth are related and their impacts are related. So I would like to finish with two questions that are aimed to be a little bit more fun on the matter. What, in two words, how would you describe the research on space debris, or the case of space debris? Is it
terrifying and manageable? So I can elaborate a little bit. It's very scary, this impending destruction of all of the satellite infrastructure. But since it is such a man-made problem, we can really make a difference in solving it just with some laws and regulations and better behavior, and we don't have to reach that tipping point.
Okay, so there are solutions, which is something that the report does get into as well. And then my last question would be, what is the most interesting or fascinating part about the space debris case?
I think it was really fascinating to find out just how many objects are up there, and the ones that are more weird. So in researching this, you find out that there's lots of discarded rocket stages, there's old satellites, there's also a lunchbox, there's a wrench, there's a glove, things that, you know, went missing from the space station that somebody just accidentally dropped it. It's actually interesting to think that those things are up there floating above our heads.
Yeah, perhaps that's sort of the crux of this case, is that the more we send up, or we're sending so many things up, that we're finding these items that are just sort of random, I think. Well, thank you very much, Kate, for your time. We're very happy to delve into this issue of space debris. Please stay tuned for more science talks. We look forward to talking about all things science and the way it applies to you.